Fracking is destroying water, is the claim, in the Karoo especially. And I'll go to you, Craig, on this one first. As a water lover.
Yep. What do I think of fracking? I'm an engineer and I'm a pragmatist. So I'm also a realist. We need hydrocarbons. There's no doubt about that. We're not into a green economy yet. It's going to take us some time. In the US, fracking has changed the global energy landscape. This is a reality. I think last month's National Geographic was all about how the US has changed and what fracking is doing to the US at the moment. Per se, I don't have huge issues with fracking, with the proviso that the whole process is properly understood and properly controlled. So in South Africa, fracking is primarily occurring within the Karoo. The Karoo is a sole source aquifer environment. If you have a look at a groundwater map of South Africa, it's a big red blob. It means there are many people who rely on groundwater for their existence. If we don't know what people are putting into the groundwater, I have a problem with that. I have a real problem with that because I need to make informed decisions, and I don't think there should be any level of proprietary information if you are going to start putting things into public resources, things like groundwater resources. So per se, I'm not sure I'm against it unless we understand it properly and we understand what the risks are and how to mitigate those risks. There are already significant contamination issues across the Karoo. I mean, I know this. And the aquifer has been damaged in a number of locations. So that's already happened. We can't get away from this. The question is should we be doing this? And how are we going to be doing this? And how are we going to get the correct information to ensure that we don't actually destroy a sole source aquifer for generations to come? And that to me is a critical point.
Does it not create an abundance of methane gas?
It does.
Which mixed with water is an explosive issue.
It is, but you can get it out of water quite easily.
Yes, but it doesn't in this case. It's not being got out. Our filtration we were talking about before could be an issue here, but at the moment, fracking is dangerous.
It has the potential to be dangerous, for sure. And I have seen the films where people can ignite their taps. And for the life of me, I would hate to have water in my house which is oozing methane. I think that would be a disaster. So
I would think biologically your stomach wouldn't enjoy it very much.
Possibly not, although. So for me, we have to understand how to get those issues sorted out before we can have not even public, personal acceptance of the technology. And I think there's a lot of research that needs to be done to understand how the hydraulic fracturing occurs, how the gases move around beneath the aquifer, and what comes back in terms of the water.
Now, I know Sonny's nodding his head in complete agreement here, but he's got another one of his inventions that is very much up in the air at the moment. So I'm being a little naughty asking you to talk about something that isn't proven yet. But you are experimenting with carbon, aren't you?
Yes. Another idea which we have in our labs is we work on nanotechnology. At the moment, people use silica or sand.
Correct.
In pores in the reservoir to keep the aquifer what it should look like or it should be. Now, people are also researching in using nanosilica, nanoparticles of silica. Since my students are already creating beneficiation from carbon dioxide, and people have proposed that carbon dioxide instead of water can be used for fracking. And a lot of people are already storing carbon dioxide underneath the ground. So what we want to propose is we can make carbon nanotube in situ in the reservoir or in the shale, which means as you take the gas out, carbon nanotube, using carbon dioxide, carbon nanotube is produced right there, taking the space that will be left behind when the gas is released, and enabling the gas also to come out. So there is recovery, there is protection, there is reformulation, and so on and so forth. So there's no issue of water. There's really no pollution. You are using carbon dioxide, meaning you are getting it from who is producing it. For example, the power plants. You pipe that to the Karoo and put it in there, and you use it and store it forever. And carbon will stay for thousands of years.
Now, why can't the mines use this, Craig, for their fluent that they're dumping out into the rivers? If one goes to the agricultural situation, many farmers, especially on the Vaal,
Right.
are approving beyond a shadow of doubt that effluent is creeping into their land. Cattle are being diseased, people, school children that live on the banks that are from a lower poverty level are becoming ill. We are reaching levels now of a proportion that is disturbing, to say the least. Can we cure that problem with what we're talking about today?
The carbon nanotubes.
Yes, in the mining industry. Or how do we, from your point of view as the water lover, how do we stop that water being polluted?
I would like to define what the pollution is for a start, because I think if we know what's causing the pollution, then we know how to stop it.
Well, it's dumping from the mining industry, most of it.
Well, there's a whole bunch of different types of pollution. So we have surface dumps, where we have plumes of salts and things which can leach into the groundwater. We know we have acid mine drainage type issues. These are all quite different pollution types of sources. So one size fits all may not work. The only one size fits all that does really work is reverse osmosis. And that's being done currently in Witbank. So they have currently, it's Anglo-American, they've installed a reverse osmosis plant and they're producing potable water for people to drink as part of their corporate outreach project. And that will work. And that will work for any water stream which is contaminated with salts.
In other words, acidic water.
Acidic or alkali or neutral, because mine drainage doesn't have to be acid or alkali, it can also be neutral. So, and that's just about the pH of the water. So that's getting rid of the salts, and you can do it. But the point of that is it's very expensive. It uses a huge amount of energy currently, and we're already in an energy pinch with Eskom not able to supply us with enough. So we can't really build these large-scale type plants to do this. In terms of the proposed short-term solution for acid mine drainage in Johannesburg, we're looking at the high-density sludge process. It will get rid of the most of the metals. It will get rid of iron, it will get rid of uranium, it will get rid of most of the things which are a problem. However, it leaves residual sulfate because of the kinetics of how it works. And to me, this is an area we need to investigate quite carefully, is how to get rid of those sulfates. And there are lots of different ways, but they are all expensive or they take a lot of time. And if something takes time, you normally need a lot of land space, and then it becomes expensive once again. Myself and 3 other co-researchers are looking at, we're trying to see if there are ways of actually preventing the formation of acid mine drainage. So to produce to produce the acid, you need water, you need oxygen, and you need sulfur, and you typically need some kind of a microbe to do the work. That's the catalyst. So if you can get rid of one of those 3 or 4 ingredients, you can stop producing acid. And we're in the process of discussing with the Water Research Commission a project where we look at actually extracting water from deep underground to hold surface levels constant. Because at 2 kilometers underground, there's no oxygen in the water. So you can't create acid down there. So as your aquifer fills up, that area becomes oxygen depleted. So if you can hold your surface water level steady by pumping from a region where there's no oxygen, we're hypothesizing that you'll initially deplete it you'll suck up acid, which is there. As it was rising, it was creating acid, but you shouldn't create any more acid there. So we're hypothesizing that you'll get an acid layer on the surface, and deeper down you'll actually have fresh water.
Let's talk about that nanotechnology. Do you ever see the day where one can take a needle, a hypodermic, and inject the nanotechnology in to clear away the blood vessels that are clogging hearts? I mean, it's like little animals. They're like little ants, if you can imagine, cleaning away all this awful stuff lining the tubes.
There are a lot of stuff one can think about. You know, when I started Nano here, I proposed nano robotics, which can be in the bloodstream.
That is the robotic side I was talking about.
Exactly, which can go about, even chase HIV virus.
Yes.
You know, in the blood, for example. My friend was saying, Sonny, this is too wired. We can't do that. But I started the research. Yeah, but I'm not an electronic guy. I'm a mechatronic guy. But I started something very close to that, which has to do with cancer. For example, I don't know if you know cassava. You know, cassava is grown in West Africa, Zimbabwe.
It's a root.
It's a root, exactly,
Yes,
exactly.
yeah.
See, that cassava has naturally protect itself against rodents and ants and animals and so on. So if rodent, for example, bites the cassava stem, it releases that white sap. Now, that white sap contains two chemicals, linemarine and linemarase. When they meet, because it's wounded, they meet and react and release hydrogen cyanide. And you know what hydrogen cyanide is? It's poisonous.
It's
It kills.
poisonous, yes.
So kills the rodent and kills you and I if we were to get there. So what we did is we actually planted some of that in our a space here, which the university gave to me. And what we did was get this linemarine, put into nanoparticles, encapsulate into nanoparticles, and the linemarase into another particle. Now, we'll coat them with antigen antibody kind of stuff. So when you inject it into the blood, kind of antigen, which will be recognized when it gets to the site where cancer is. So it goes right there and attach itself there and release the venom and kills only there. So that will be, so instead of going chemotherapy, for example, where all your hair going to drop and you suffer for months and doing chemo, you just do this. Put the injection right there. It travels through until it gets to where the antigen antibody meets the cell and releases the venom and kills the cells. I graduated a PhD and 2 master students here who did that research, and we were able to we did try on human. We were able to kill breast cancer, ovarian cancer, and leukemia. Leukemia moves around, but at least where we immobilize.
You actually have succeeded in doing this.
Yes, I have the results here, man. I have the result. But the guy who was working with me, I don't want to mention names, was saying, we were collaborating from medical school. He said in the old Chinese herbal practice, they had used cassava in the past to treat people in Mexico. And all the people treated actually died after 5 years. But again, that was crude. But what I'm saying is, with these nanoparticles encapsulated in nanomembrane, linemarine and linemarase, you put just the quantity required to kill the cancer cells. So it goes right to the point of where the tumor is, and it gets released there and kills the cells. So it doesn't kill the cells around it. It's only that point.
Why isn't it going any further? Why don't we hear about this?
Yeah, I think maybe. Also, I was funded by the Griffith Cancer Trust Fund, in 2005 when I started that research. But I think 2007, I'm not sure what happened to it, but I was told the trust stopped. And yeah.
So many people that may be reading and going to watch this, you may be getting some phone calls very quickly, very soon. Because
no problem. We have the results.
I think I'm hearing amazing things.
Yes.
And if it wasn't for the fact that you're at a reputable university and you're a professor, I'd be calling you crazy.
Yeah.